Caproni Ca.60 Noviplano. The Caproni Ca.60 looked less like a flying boat than several aircraft that had crashed into one another and somehow remained connected. Italian designer Gianni Caproni believed enormous passenger aircraft would eventually cross the Atlantic. In 1921, long before commercial aviation had proved such journeys practical, he attempted to build one. The Ca.60 had a boat-shaped hull, 8 engines, and 9 wings arranged in 3 separate stacks of 3. The design reused triplane wings left over from Caproni's wartime bomber production, creating an aircraft that appeared to have been assembled according to the principle that anything capable of flying would fly even better if repeated 3 times. It was intended to carry around 100 passengers across the ocean. The cabin resembled the interior of a ship, while the pilots sat in an exposed cockpit above it. 8 Liberty engines drove a complicated arrangement of pulling and pushing propellers. During an initial low-speed test on Lake Maggiore, the machine briefly left the water. On March 4, 1921, it attempted another flight, climbed only a short distance, then pitched upward, stalled, and crashed back into the lake. The pilot survived, but the aircraft was badly damaged. Caproni planned to rebuild it. The cost made that impossible, and the surviving wreck was later destroyed by fire. The K.60 was not simply an aircraft with too many wings. It was an ocean liner designed before aviation had learned how to build the bridge between an ocean liner and the sky. Dornier Do X. The Dornier Do X was so large that its engines required their own engineer. First flown in 1929, it was the largest, heaviest, and most powerful flying boat of its era. 12 engines sat above the wing in 6 paired nacelles, with 1 propeller pulling and another pushing from each position. Its hull contained 3 decks. Passengers could occupy sleeping cabins, a dining room, a smoking room, and lounges decorated more like spaces aboard a luxury ship than the interior of an aircraft. The cockpit crew did not directly control the engines in the familiar way. Engine commands were transmitted to an engineer in a separate control room, who adjusted the 12 power plants. On one demonstration flight, the Do X carried 169 people, establishing a passenger record that remained unbroken for more than 20 years. The aircraft could fly, but not efficiently. Its original engines overheated and struggled to lift its enormous weight. A journey from Europe to New York became a 10-month sequence of delays, repairs, accidents, and publicity stops. Wherever it appeared, crowds treated it as proof that the future had arrived. Airlines treated it as proof that the future was extremely expensive. Only 3 were built. The Do X successfully demonstrated that a multi-deck passenger ship could leave the water. It also demonstrated why almost nobody could afford to operate one after it did. Blackburn B-20. Flying boats needed deep hulls to survive takeoffs and landings on water. Unfortunately, those same hulls created drag once the aircraft entered the air. The Blackburn B-20 attempted to make part of the problem disappear. Built in Britain and first flown in 1940, the experimental aircraft had a lower hull that could retract upward after takeoff. On the water, the extended section gave the aircraft the depth and shape required to behave like a boat. In flight, it folded into the main fuselage, producing a slimmer body with less aerodynamic resistance. Even the wingtip floats were designed to fold outward and become streamlined extensions of the wings. The concept was ingenious because it acknowledged that a flying boat was being asked to possess 2 contradictory shapes. It needed to be a stable boat while touching water and an efficient airplane everywhere else. The B-20 physically transformed between the 2. Tests suggested that the retractable hull system worked, but the only prototype was lost in June 1940 after severe vibration developed during a test flight. 3 crew members were killed, while 2 survived. The accident was not blamed on the retractable hull itself, and Blackburn later proposed improved versions. None entered production. The B-20 solved one of the flying boat's oldest compromises by constructing an aircraft that carried one body for the water and another hidden inside it for the air. Hughes H-4 Hercules. The aircraft commonly called the Spruce Goose was neither made primarily from spruce nor intended to be a novelty. During the Second World War, German submarines threatened Allied shipping in the Atlantic. Industrialist Henry Kaiser proposed transporting troops and equipment above the submarines in enormous cargo flying boats. He joined Howard Hughes to develop a machine capable of carrying hundreds of soldiers without using strategically important aluminum. The resulting H-4 Hercules was built mainly from birch using a molded plywood process. 8 engines powered a wingspan of approximately 320 feet, larger than that of any aircraft that had previously flown. The war ended before the aircraft was completed. Costs increased, deadlines passed, and the project became the subject of a government investigation. Critics suggested that the giant wooden machine would never leave the water. On November 2, 1947, Hughes conducted taxi tests in Long Beach Harbor. During the final run, he increased power and lifted the Hercules into the air. It remained roughly 70 feet above the water, traveled for about a mile, and landed after less than a minute. It never flew again. Hughes continued paying to preserve it in flying condition for years, keeping a full maintenance crew assigned to an aircraft whose entire flight history lasted shorter than many airport announcements. The Hercules was built to cross an ocean carrying an army. Its greatest journey was 1 mile, but that mile prevented anyone from truthfully calling it incapable of flight. Saunders Roe Senior A/1. The Saunders Roe SRA/1 was a jet fighter designed to operate from the ocean. During the Second World War, the Pacific Campaign suggested that fighter aircraft might need to operate far from conventional runways. Saunders Roe proposed combining the speed of a jet fighter with the independence of a flying boat. The result had the fuselage of a compact fighter, a boat-shaped underside, stabilizing floats beneath the wings, and 2 jet engines mounted high inside the body to protect them from sea spray. It was armed with 4 20mm cannons and was intended to take off from sheltered coastal waters, attack enemy aircraft, and return without requiring an airfield. The first prototype flew in 1947, making the SRA/1 the world's first jet-powered flying boat. Pilots generally found it pleasant to fly, and its performance was respectable. But the strategic problem it was created to solve was disappearing. Aircraft carriers were becoming more capable. Land bases were spreading, and jets required maintenance support that was difficult to provide from an isolated stretch of ocean. 3 prototypes were constructed. 2 were lost in accidents, and the surviving aircraft was eventually preserved. The SRA/1 was a successful answer delivered after military aviation had stopped asking the question. It turned the sea into a runway, just as carriers made bringing a runway with the fleet considerably easier. Saunders Roe Princess. The Saunders Roe Princess was built for a passenger age that vanished before it could arrive. After the Second World War, Britain still imagined that enormous flying boats might carry travelers across the world in luxury. The Princess was designed as a pressurized, double-deck airliner capable of carrying more than 100 passengers across the Atlantic. It was powered by 10 turboprop engines, although the arrangement made the number difficult to recognize. 8 engines were paired inside 4 nacelles, each pair driving contra-rotating propellers. 2 additional engines drove conventional single propellers. The aircraft was enormous, graceful, and technically complicated. Its hull rose from the water like a passenger liner, while its high wing carried an engine system that demanded more mechanical cooperation than the available technology could reliably provide. Only 1 Princess ever flew. Its first flight occurred in August 1952, but engine and gearbox problems repeatedly delayed development. Meanwhile, long concrete runways had spread across the world, and land-based jet airliners were beginning to make even advanced flying boats look slow. The Princess was not defeated because it could not fly. It was defeated because airports developed faster than its engines, leaving Britain with a majestic ocean airliner whose ocean was no longer necessary. Martin P-6M Seamaster. The Martin P-6M Seamaster was a nuclear bomber that intended to hide on the water. During the early Cold War, the United States Navy feared that land-based strategic bombers gave the Air Force too much control over nuclear missions. Its solution was a jet-powered flying boat that could operate from remote bays and be supported by ships or specially equipped submarines. The Seamaster carried 4 jet engines above its swept wings to reduce the amount of spray entering them during takeoff. It could fly close to the speed of sound at low altitude and was designed for nuclear strike, reconnaissance, and high-speed mine-laying. Unlike many strange experimental aircraft, it came remarkably close to operational service. Production examples were built, and Navy crews had begun training. But the program was troubled. Both original prototypes were destroyed in accidents, killing 1 crew and forcing the other to escape. Development continued, producing a faster and more capable version, but costs increased while the aircraft experienced control and water handling problems. Then the Polaris ballistic missile submarine arrived. It could remain hidden underwater for months and launch nuclear missiles without requiring a giant jet to accelerate across a rough sea. The Seamaster program was cancelled in 1959. Every complete aircraft was eventually scrapped. The P-6M was one of the fastest boats ever placed in the sky. It was also a nuclear weapons system rendered obsolete by another machine that could remain beneath the water instead of struggling to leave it.